Hello everyone! Today I would like to review configuration of dynamic trunking protocol and EtherChannel. So let's get started. Today I'm gonna use very simple network diagram where I have three switches SW1, SW2 and SW3. And I have multiple links between my switches. I have two links between switches SW1, SW3, two links between switches SW2, SW3, and four links between SW1, SW2 switches. I'm gonna bundle these links in different Ether channels and see how it works. So let's move on to configuration. Switch uses DTP protocol to negotiate a link as a trunk link between two switches. There are few modes in dynamic trunking protocol: dynamic auto and dynamic desirable, and we can manually set a link as a trunk link or as an access link. If both ends of the link are in dynamic auto, switch will not form trunk link. If both ends are in desirable mode or one end of in desirable mode and the other end in auto mode, switch will form trunk link. And in desirable mode, switch actively trying to negotiate trunk link. The other thing which is worth mentioning is DTP datagrams continue to be sent if the port is set statically to trunk mode. But if the port set statically to access mode, both sending and receiving datagrams on that port are deactivated. So let's go and try to see what we have. For example, we go to switch SW1, show interface G01 switch port. And we can see that our switch has administrative mode dynamic auto, which as I said, default mode, and operational mode static access, and negotiation of trunking on. So if switch receives datagram from desirable port from the other end of the link, it will form trunk on this link. So let's go and try. We go to switch SW3, enable, show interface G10, show interface G10 switch port. We can see that this link also dynamic auto, that's why there is no trunk, and negotiation of trunking on, and operational mode static. Conf T interface G10 switch port mode dynamic desirable. Let's go to our switch 1. And now we can see that operational mode trunk, and show interface G10 switch port operational mode trunk. Let's try to configure this interface as access port. Interface G10. As I said, in the access mode, both sending and receiving datagrams on this port are deactivated. So switch port mode access. Show interface G10 switch port. We can see that negotiation of trunking off, operational mode static access, and let's go to our SW1. We can see that operational mode static access and negotiation of trunking on, because this port is still in dynamic access, or dynamic auto, sorry. And this on SW3 is static access. Let's configure to trunk. Conf T switch interface G10 switch port mode switch port trunk encapsulation .1q switch port mode trunk. show interface G10 switch port. Now we can see that administrative mode trunk, operational mode trunk, encapsulation.1q, negotiation of trunking on, and our SW1 switch should be also in trunk. Operational mode trunk. And we can also check show interface trunk. And we can see the G01 interface, mode auto, status trunking, and SW3 show interface trunk. We can see that mode on. In dynamic desirable, it's gonna be desirable. Let's do it. Conf T interface G10 switch port mode desirable. We need to deactivate, dynamic desirable. Show interface trunk. Mode desirable. And let's configure native VLAN. Conf T interface VLAN, let's say 999. Interface G10 switch port trunk native VLAN 999. And we need to configure on SW1 as well. Conf T VLAN 999 interface G01 switch port trunk native VLAN 999. Show interface trunk, and we can see that native VLAN 999 and status trunking. And the last thing, if we, for example, want to disable negotiation, first we can put port in access. To make it statically access, conf T interface G10 as I showed, switch port mode. We need to disable actually trunking. No switch port trunk encapsulation .1q, and then we need to put it statically to switch port mode trunk. Access. To show interface G10 switch port, and it goes statically to access and negotiation off. But for example, interface switch port trunk encapsulation .1q, or let's say switch port mode trunk is auto, cannot be configured to trunk. Switch port and trunk encapsulation .1q switch port mode trunk. And if we want to disable sending and receiving datagram on this port, we can go and configure switch port no negotiate. Show interface G10 switch port. And we can see that negotiation of trunking is off, operational mode trunk, administrative mode trunk, but this interface is not gonna be trunk. Show interface G01 switch port. And we can see operational mode trunking, conf T interface G01 shut, and show interface G01 switch port. And we can see that operational mode static access, but we have still negotiation of trunking on and our port is dynamic auto. And even if we change to dynamic desirable, conf T interface G01 switch port mode desirable, dynamic desirable, show interface G01 switch port, We can see that dynamic desirable, static access, negotiation on. Let's do again interface G01, shut, no shut. Show interface G01, switch port. Negotiation of trunking on, but our port still in operational mode static access. So there is no negotiation because negotiation is disabled on the other end of the link on switch SW3. Let's review EtherChannel. There are a few advantages of using EtherChannel. First one, we can increase bandwidth of the link between our switches without upgrading links itself. For example, we can use two physical links between our switches. Each link is 1 gigabit. We cannot use them without bundling into EtherChannel because in this case, spanning tree will block one of the links, avoiding a loop creation. If we bundle them into EtherChannel, we're gonna have one 2 gigabit link between our switches, and STP will not block physical links in this bundle. If we lose one link in our logical EtherChannel, and this is the next one, next advantage, we will still have link between our switches because by default EtherChannel will be on. There is at least one link between switches up and running, one physical link. And if we're losing a link between switches in our logical EtherChannel, there is no need for STP recalculation because STP considers this link as one logical link. We also can apply configuration to EtherChannel, and it will be applied to each physical interface. There are a few methods to configure EtherChannel. First one is statical. We can configure statically using configuration option on. But this method is against the best practice because there is no health check mechanism. And there are also two other methods, options, let's say. We can use dynamic link aggregation protocol, LACP, and proprietary Cisco dynamic link aggregation protocol, PAgP. In case of LACP, we can use two options, active and passive. Active option actively communicates a desire to build an EtherChannel bundle. And if we use passive, it just waits for LACP use to start to communicate EtherChannel creation. There is also option to configure fast LACP fast, because by default LACP are sent every 30 seconds. If there is no LACP received during 3 consecutive intervals, this link, for example, between SW1 and SW2 is considered unusable. But we can change it, we can configure LACP fast, and in that case this interval shortens to 1 second. So LACP are sent every second, and we just need to only 3 seconds to consider this link unusable. And the next option is PAgP protocol. PAgP also has two additional options of configuration. Is desirable, acts the same way as active in LACP, so it actively communicates a desire to build an EtherChannel bundle, and auto. We need to use both ends as desirable, or one end desirable and the other end is auto to communicate EtherChannel creation. For PAgP, we can also use two modes, silent and non-silent mode. With silent mode, interfaces can be bundled without having received PAgP packet, and we can use them to connect to a file server, for example. And non-silent mode is recommended when connecting PAgP compliant switches, and it establishes link more quickly than without non-silent configuration. For configuration today, I'm gonna configure a link between SW1 and SW2 in on, in static on, and for LACP I'm gonna configure link between SW1 and SW2, and PAgP I'm going to configure on the link between SW3 and SW2 switches. Let's start configuration. First we go to switch SW1 and I want to check spanning tree first. We can see that SW1 is the root bridge. All interfaces are designated, and cost for each interface 4, which corresponds to 1 gigabit link. I want to change this. I want to change conft switch spanning tree, pass cost method long. I'm gonna use a long method for pass cost. I want to see how it will change, how STP will change cost when we bundle these links into EtherChannel. Method long, and let's see. Now we can see that our cost for each link is 20,000. Let's configure EtherChannel. Interface range G012, interface range G012, switch port, channel group is 13, mode on. We have few options: active, passive for LACP, auto and desirable for PAgP, or on. And as you can see, if we configure on, our port channel will be created and it will be in state up. To show EtherChannel. Summary. You can see that our EtherChannel is working and up. But if we go interface range and configure for LACP, G103 channel group 12 mode, I'm gonna use desirable, active for LACP, active, and we can see state is changed to down. Now is LACP currently not enabled on the remote port. Show EtherChannel summary, and we can see that our switch has ports with S. Let's see what S means. S means is suspended. They are waiting for the other end of the link to be configured. Let's go to SW2 switch. Conft interface range G103 channel group 21 mode active. And two links to SW3 switch. Interface range G012 channel group 23 mode desirable for PAgP. Show EtherChannel summary. And now we can see, and we can also check on the SW1 switch, that our port channel is up. P means that interface bundled in port channel, and SU means layer 2 and in use. This situation means that our port channel up and working. Let's go to last switch, SW3 conft. Oh, sorry, I forgot to configure spanning tree method. Spanning tree path cost method long. Let's go here, conf t, spanning tree, path cost, method, long. Interface range G201, channel group 32, mode desirable, and interface range G01, G01, channel group 31, mode on. Let's see what we have now. Show EtherChannel summary. We can see that we have two EtherChannels created on this link. Both of them are up. This link is PAgP. And on this switch, show EtherChannel summary. We can see that one link is LACP and the other one is PAgP. Let's see what we have for spanning tree. Spanning tree, show spanning tree. For spanning tree, we can see that a role of the port 3.1, which goes to SW1 switch, is root, and cost of this port 10,000. If you remember, we had show spanning tree. We have in the beginning we had all our ports cost 20,000 when we just configured pass cost method without bundling any interfaces. And now we can see that on SW1 switch, EtherChannel 1.2 has cost 5,000 and for 1.3 10,000. Here we have two links, each one 2 gigabit, and cost is 10,000. And cost to our root bridge is 10,000, which is our one bundled EtherChannel. For SW2, show spanning tree summary. Show spanning tree. We have also root 5000, where we have 4 gigabit link EtherChannel, and pretty much understandable situation. When we bundle links, we increase bandwidth, and STP considers the cost for this link lower than for without bundling. For EtherChannel verification, we can use some commands. First is I already showed, show EtherChannel summary, where we can see our channels if they are up and running. Next, we also can check configuration, or we can check our interface, our bundled port channel with command show interface port channel, let's say 2.1, and we get the same information if we check, for example, just gigabit Ethernet. We can see that channel is up, link protocol is up, bandwidth 4 gigabit, etc, etc, etc. Show EtherChannel port. Here we can see all our EtherChannels and ports in those EtherChannels. We can see flags configured, we can see priorities. We have also command show, for example, this is our switches SW2, LACP neighbors. This command shows neighbors, so it means that on the other end of this link we have port G1, 0, 1, 1, 1, 2, 1, 3, priority of the ports, and the flags. It shows that device is requesting slow LACP DU. And the same configuration, the same command we have for PAgP. PAgP neighbors, but this one is showing so our port and partner port. This is our SW2. So local port, partner device ID, and also flags. We can also check counters. Show LACP counters. We can see that how many LACP dues sent and received. Show PAgP counters. And we can see the same information for PAgP. LACP protocol can have as many as 16 signed members, with 8 active ports assigning traffic and the other 8 on standby. Switches involved in LACP bundle negotiate master-slave relationship, where master switch makes the decision on which member are active and which are in standby mode when the number of members in the bundle exceeds 8. Which switch is gonna be master or which switch is gonna be slave is based on the system priority. System priority conf-t LACP system priority. System priority can be configured in the range from 0 to 65,535, and by default show LACP system ID. System priority is 32,768, and switch which has a lowest system priority is gonna be master switch. If both switches has the same default system priority 32,768, switch which has a lowest MAC address is gonna be master switch. We can influence on master slave switch selection by changing system priority conf-t and then LACP system priority, and we can use priority value. So master switch which will choose which port is gonna be in bundle if our number of members exceeds, for example, 8, or if it exceeds a maximum bundle number configured for this port channel. In that case, if all ports have the same port priority, switch will use first ports by port number. But we also can change it. We can go to our port, for example, let's say conf-t interface G10, and there is option LACP port priority, and we can change it from 0 to 65,535. Show LACP neighbors. We can see default priority on our neighboring switch, and we can also, as I said, we can configure max bundle, which is the max number of ports bundled in our port channel, and we also can configure minimum number of ports with the command port channel min links and the number of links. But on my platform I don't have this option. I can configure only max bundle, so I'm gonna do it conf-t interface port channel to 1, and I'm gonna use LACP max bundle, and let's say 3. In this situation, first 3 ports G10, G12, G1 and G11 will be bundled into EtherChannel, and port G13 physical port will be on standby. Show EtherChannel summary, and we can see that our 1.3 port is on the standby. Let's go to our switch SW1 conf t. And on this switch, let's say we're gonna configure the same interface port channel 1 2 LACP max bundle 3. Situation is not gonna change, but switch SW1 now is master, and we can see it, for example, conf t, if we change priority of our G13 switch. Let's just check what we have now. Show LACP neighbors. Priorities for all interfaces, for all ports are the same. Show EtherChannel summary. We can see that G13 is in standby mode. Let's go interface G13 and change it LACP port priority, let's say 1. Show LACP neighbors. Let's wait a little bit. We're gonna see priority of G13 equal 1. Oh, I'm sorry, I changed G10. No, interface G13 LACP port priority 1. Let's see. Let's wait a little bit. Now we can see this port changed to default value, and now we need show IP interface brief. We need our G13. Show IP interface brief. G13 is up. Let's wait. 8. I'm sorry, conf t. I found mistake. I put the same command, no LACP port priority. Conf t interface G13 LACP port priority 1. It happens, sorry for wasting time. Let's see now. And now we can see that LACP port priority 1. Let's see, show EtherChannel summary. But still G13 interface is in standby because SW2 switch is not master. If we change on SW1 switch, it will accept it and G13 will be bundled, and then G12's interface will be in standby. Conf t, let's see if I am right. Interface G12 LACP port channel, port priority 1. Show EtherChannel summary. Still G13 in standby. Show run interface G13. Probably I configured something wrong again. I configured G12. conf t interface G12 no LACP port priority 1 interface G13 LACP port priority 1 show EtherChannel EtherChannel summary. Let's wait, and now we can see that I was right, and 1011 and 13 are bundled, and G12 waiting to be aggregated, and now it's in standby, hot standby. And the last feature which I wanted to review is load balancing. A load balancing method is global setting for the switch, and the load balancing method can be used at each end of the link separately, and it doesn't have to match on both ends of the link. So to check which method, load balancing method we are using at our switch, we need to use show EtherChannel load balance command. And we can see that for this switch we use source destination IP. To change this method, because in some situation it is useful to use one method, in some situation it is useful to use the other method. To change it, you need to use global configuration mode command port channel, and here we have a load balance, and for each platform the number and the type of method of load balancing method are different. So for example, for my platform I can use destination IP, destination MAC, source destination IP, source destination MAC, and source IP and source MAC load balancing methods. There is also option to check what interface the load balancing algorithm will choose. This command is show platform software fed EtherChannel. Then we have switch number, channel group number, and group mask or load balance MAC, source MAC, destination MAC, IP, source IP, destination IP, port, source IP, destination IP options. For example, let's say we can use show platform software fed switch 1 EtherChannel 1 2 load balance, and then we can use MAC address, source and destination MAC address, and then we will get which destination port switch will use for this frame. Thank you very much for watching my video. I hope you enjoyed it. Please don't forget to subscribe to my channel with the notification bell on, and show your support by hitting like button. I hope to see you soon in my next videos, but for now just goodbye and see you soon.